recording. Okay. So, just a few notes. I will be trying to monitor our chat window. Feel free to also interrupt me and ask the question via voice. If I'm explaining something not precisely, then feel free to interrupt me and ask the questions. We will have a Q&A session in the end. I will try to keep this presentation finishing in 1 hour, then about half an hour Q&A. But feel free to ask question in the meantime. Let's keep this meeting a chance to also interact and discuss things, not just like a simple webinar. Okay, let's go. So we'll be talking today about the strategies and the basic approach on migrating a typical CRUD application into an event sourcing system. Let's imagine for now that we will be building, and we were building, an e-commerce platform. So we managed to get into production. We have already something that is working. We have customers, we are operational and even profitable. But it appeared that our business found out that that's great that we are able to sell stuff, to find customers that will be using our SaaS platform. We have already shopping cart handling, etc. But it would be good to have something more, because as we stabilize at the certain scenario and certain place, then it would be great if we could expand from that. So maybe, for example, doing an abandoned cart analysis. Before I started to be developer, I was struggling to find a first job. It was like 15 years ago, over. And my first jobs during the summer break were in the sports clothing shops. So I was explicitly selling Adidas and Reebok, etc. Clothes. And our biggest trick to get our customer was to persuade that person to try out, for example, to sit down and try out the shoes. Because when the person was already trying it out, then the chance that they will buy something was increasing extremely high. So in the e-commerce industry, there is a concept of abandoned carts. And abandoned carts are those that someone put something in the shopping cart, but then decided to just, close the page, never got back, or decided to drop the shopping. So it appears that those abandoned carts, depending on the measurements, it's like about from 82 to 90%. I saw that the best achievement was like around 60%. So it's like almost 30% difference between those that are the best in getting the deals closed and those that are not doing the great job. And the reasons why people are not buying and dropping those things that they selected might be different. So for example, we might have just bad user experience. People might not be sure enough that they would like to buy, or for example, our system is buggy. We have some edge case that is not allowing people to close the deal, or our web page is just working too slow. And getting back to my example of persuading people to try something out, when we have someone that is eager to try something or put something into the basket, then there is a much higher chance that this will be our customer. So instead of doing like a cold calling and cold marketing, so trying to get people that are not interested in or might not be interested because we don't know whether they would like to buy something, maybe it's much more effective to focus on those people that were already so close to buying things because they already put something in the shopping cart, instead of just trying to just go broadly and advertise to anyone. The other thing is, in our shopping cart example, is the shopping cart analysis. So we can gather information about the products that were put into the shopping carts and that were bought together. And then we can start with the most easiest example. So finding out the percent, so the support of how often this specific product was selected in all of our shopping carts. Having that, we can build also and make measurements and find out what's the confidence that if, for example, someone buys champagne, then it will also buy some bouquet of flowers or chocolates. Or and then we can find out, knowing that, what's the probability that if someone decided to buy a champagne, then what's the probability that we can recommend this person to also buy a box of chocolate. And by having that, we can not only increase our sales, but we can even, of course, not always, but sometimes help people to make the right decision. And that works really well, for example, in Amazon. Um, I think that I'm not the customer of non-books part of the Amazon, but those recommendations that I see on like IT books are extremely precise and are quite helpful to digging and finding other books that I would like to read. So based on that, we can do some measurements, we can find a specific values. And at the end, based on that, we can build even such graph, maybe use even machine learning. I know that people are doing that, and build the dependencies between our products. And I explicitly chosen to use the shopping cart example because quite often when I'm talking with people, then they are saying, yeah, why are you showing shopping cart if that's, you can solve that by CRUD? And yes, you can solve that perfectly by CRUD. You can go to production, etc. But if you'd like to expand and make your options better and just have the versatility, then you might sometimes want to have something more. And let's maybe discuss our current system architecture. So how did we start with our e-commerce SaaS platform? So talking and naming that architecture is a bit exaggeration. So we have cloud hosting where we store Docker image with our Node.js application. We are using Postgres, so typical relational database. And of course, we are using single page application. So single page application is also dealing with the business features complexity. So it's really a rich client. And in fact, our API, current API, it's just, we could call it like a database pushed and forwarded to the UI. And our current database structure looks like that. And it's only a part of that. If this image and this diagram is too small for you and it's unreadable, then it's on purpose, because this is really unreadable. If we are making our system, designing it just by some random boxes put and connected together, then it's hard to find what is the real business process. Because of course, by looking at the data, we can more or less guess what's happening, even by the tables, names and definition. However, what we already saw is that not only data is important nowadays, but also understanding of the process and being able to record the specific step of the business workflow. Um, we will be focusing today on the really small subset of this subset presented in the previous slide. So the shopping cart. So as you see, we have a shopping cart and related table with the shopping cart items. There is nothing spectacular here. We have a shopping cart with the information about the user. So like a first name, last name, its ID, etc. But what's the most important is that our current assumption is that we will use all the features that we have from the database. So foreign keys, unique constraints, etc. And frontend will run the business logic and push it to API, and API will just do the basic upserts. And we will be hoping and that the database structure will also guard us from doing stuff that we do not intend to do. Okay, so this will be also a hands-on experience. So let's just go into the code. Let me find my IDE. So let's have a look on what we have in our shopping carts API. And API is, again, exaggeration because we have two endpoints. One is for getting the shopping cart ID by ID, so getting all the details with all the product items. And the other endpoint is just upserting, as I mentioned, the shopping cart. So no matter if we are opening shopping cart, adding product to shopping cart, confirming it, etc., we are just using this specific endpoint. And I will be showing the examples using Node.js and TypeScript, but if you prefer any other languages, then I think that you could easily transfer that into your favorite dev environment. So it's not about technology, but the general feeling. So let's have a look what's happening here. So at first, we are getting the user session because classically, if there is a shopping cart, then at first it's anonymous and user should log in only after they are confirming. I think that you for sure know that part from even using the online shopping. Then we are getting data from the shopping cart from request, and we are doing here a really basic validation, just checking whether it's defined, it's a string or number. So just a basic semantic validation. After that, we are just at first doing upsert to shopping cart. And we are even so blatant because we don't care about what's the process and whether we are deleting or not. Then if we are appending the shopping cart product items, then at first we are deleting all those that were there and then just doing bulk insert and recreate and put the new state. As we are not caring about the history, then that can be something that is the easiest and the most achievable, at least in our bootstrapping phase, where we just want to go through the first validation and just get that done and going and running on prod. So did anyone did similar code like that in the past or saw that in your past projects? I unfortunately did similar stuff. So then getting is again a simple stuff. We are just using find one. If we found it, then we are returning it. If not, then we are just returning 404. And I'm using here a basic ORM, which is the @database. It's a nice tool for that job in the Node.js land. But as you see, we are using all of the potential CRUD-ish components that we could have. So let's get back to our slides. And then what to do and how to increase and how to help us to get more information. So to be able to, for example, analyze what was going on in our shopping cart, why people dropped uh, the shopping cart. So I think that it won't be surprising for you, as you already know me, that maybe the answer will be the event sourcing. And maybe let's briefly discuss what's event sourcing about. So event sourcing, the, the most foundational component is event. Event is a fact that was recorded for the specific thing. Like, for example, shopping cart was open, product added to shopping cart, product removed from shopping cart. So all of the business facts that happened for the certain object. If we have more objects, then we have more events and more streams, because event stream is an ordered sequence of events. So we can think about event streams as comparing that to classical approach, it would be like a one-to-one with the regular record. So what we have classically as one record in the relational table, then here we have as a stream. So it's event stream, speaking differently, it's just the identifier of the record plus all the events that were registered for that, for that specific object. And then event sourcing quite often, not always, but most often, gives us possibility to also see the whole history of our system, because most of the event stores, so databases used for storing events, allow to see also the correlation globally. So see the whole history and order of appearance of all events inside the event store. And let's just see how event sourcing works and compare that to classical approach. In the bottom right corner, you have a table, and table is showing how this would look like and what would be the result of the operation for this specific thing. And on the left side, you will have how that looks like in event sourcing. So in event sourcing, the result of each operation is a new event. So when we open shopping cart, then classically we would just add a new record into database. In event sourcing, we are creating and appending new event to the specific stream. Then when we are making, for example, update, then in a classical approach, we would update some record in the database. But in the event sourcing, we are just appending again a new event. And if we are removing some data, like for example, removing product from the shopping cart, then we are typically we either delete data, or like in this example, we are just updating and decreasing the product count. In event sourcing, it's again event. So no matter what's the type of operation, then it's always an event. And here we already see the benefit and the potential example where event sourcing shines, because have a look and compare the state after the first event and after we added and removed the product item. In event sourcing, we clearly see what has happened. And in classical approach, we already have lost the business data. So we don't see whether the state and the product count is 0 because we just opened shopping cart, or because we added some product and we dropped it. So we are already losing data. And we can say that, yeah, but relational databases are durable. They are not losing any data. They are, because we are saying them and we are overriding the data. So it's durable. The new state is stored durable, but we are losing information about all the previous states and all the previous transitions. So here we already see that even if the simple example, we might be losing data. And nowadays, storage is cheap, but information is priceless. So someone might say that, okay, but we in real life, we are not just updating the state like you showed here. We are not using just a single table, but we are using two tables. So we have a shopping cart table and product items table. And I already showed that in the one of the previous slides. So let's have a look if that will help us somehow. And in the middle, you can see how the event payload in the JSON format could look like. So if we open shopping cart, then we are adding new record into shopping carts table. If we added product to shopping cart, then we are adding new item, new row to products items table. So far so good. So let's see what will happen if we removed product. Then again, this additional table didn't give us any benefit because we also lose the data. And we can say that, yeah, but we could use the soft delete and mark just this record as soft deleted, and we would see that this record existed at some point. But yeah, but then we see that we are losing again. The more tables we have, the harder is to understand what has changed. Because if we get back to previous example, then we were just changing only the single table and we knew where to look for the data. But if we have a look here, then we are sometimes changing this table, like in the case where we are opening shopping cart or when we are confirming shopping cart. But on the in the other events, we are changing different tables. So we need to correlate data, and this is just a pure technical data. So it's not like event sourcing is a magical unicorn that will solve all the issues for us, but this is something that gives us more out of the box, more options. So I think that if any one of you were recently trying to find a bug on the production, then you for sure know that finding them in the relational star table normalized data, it's really hard to track. So let's get back to our architecture and how we could, for example, transition from those tables, so those that I mentioned, into the events. So the first step and the first thing to look for to find out events is having a look and search for all the statuses columns, because typically and quite often events are marking a transition from one state to another. So when we see that we have more than one status, then potentially those statuses can be a good indicators for knowing which events we have in system. They are not, this is not only the potential thing, but the starting point. The other is to search for dates, and dates, quite often we are recording when something has happened. So if we have something more than created at or updated at, like, for example, confirmed at, then this could be a good indicator for that. Sorry for some Polish naming here. It seems that I'm loosey, and I didn't change the Polish terms. So niewymagalne kolumny is the, so you're not only learning event sourcing, but also a bit of Polish, means that not required columns. So all of those columns that are not required are potential to find out what should be put into the initial events. So all required columns should go there, and all non-required probably will go with the further events. And even here we can clearly see that, because first name, last name, middle name, etc. So all the personal data in our process usually goes with the shopping cart confirmed event. So when user decide that they would like to buy something. And so we are in the events discovery phase. And here in our process, we could find out that, for example, we have shopping cart opened, shopping cart confirmed, and we also have events like product item added to shopping cart and product item removed from shopping cart. So nothing fancy here, but this can go further, and this is our just initial idea. Best if we work together with our business, and for example, event storming or event modeling can be a good exercise to enable collaboration between us technicians and business. After we have events, then quite often there are related comments. So mostly if we have event that shopping cart was opened, then typically we need to have a comment, so the intention to do something. It's not always that comment an event is one-to-one, but that's the most common case. So at least that's something to start discussion. And once we have it, then we can think and discuss and define business rules. And those business rules, of course, the best is to get from the business. But if we cannot, then we could again try to have a look on the required fields or some constraints or some triggers that we have on database. So it all depends whether and how we can gather this knowledge. So in our case, this will be like we cannot add or remove product if the shopping cart is already confirmed or canceled. Same, we can only confirm open shopping cart and the shopping cart that has products inside. And we cannot remove product that we don't have in our shopping cart. So those are just the basic examples of what we could come up. And having that, we can model our event sourcing process. And event sourcing process is not so far from the classical approach. The biggest thing to keep in mind, and that's why we have distinguished the commands, because to register command, we need to know precisely, to register event, we need to know what was the business intention. So if we have just a request in our API, like I show, just upsert and single page application is just taking care of everything and just showing the result of the business logic, then we won't be able to get the granular events, and we won't be able to get and understand what happened business wise. So we need to have a precise comments to be able to, so the intentions to know what business logic we need to run. And after that, but there is not much difference because we also need to send some requests through the API. We need to handle that. And the first real difference is that we are not getting state out of the regular database or snapshots or whatever. We are just getting all the events that were recorded for the particular stream. So for our business object. So in our case, all the events for our shopping cart. And after that, we are creating a default object and we are applying one by one event after an event, building the result state, so our current state. Having the current state, there is no difference what we are doing besides comparing to the traditional approach. We still need to do some validations. We still need to run a business logic. And the only difference that we have is that in the end, we need to generate a new event and store it inside the event store, because event store is in fact database. So that's why we should not be treating Kafka as event store, because Kafka doesn't have an API to get all events. You cannot just say that, give me all events for the specific stream. You can only subscribe. And it also doesn't have any guarantees around the consistency, transactions, etc. You are just putting an event on one side of pipe and getting it by subscription on the other side. So event stores are not queues. Event stores are databases. And okay, So let's see how our transition system could look like if we try to go from this particular step. And do you have any questions at that moment that I could answer before I go to show how to do the transition inside the code? Feel free to ask any questions via voice or type it on chat. When I'm just looking down, then I'm checking whether you wrote something. Okay, I don't see any questions, but feel free to ask them when they appear. So here, the initial change, and to be able to record a specific business intentions, is to add more routes, so more API endpoints. Instead of just having the upsert endpoint, we have here a post that will be opening a new shopping cart. We have then an additional endpoint for adding, for removing product item, confirming shopping cart, etc. This endpoint will look the same for getting shopping cart ID. And as you can see, and as you probably noticed, we already have this v2, and I designed to have a CRUD version and event sourced version, because I do not recommend you to just immediately rewrite the system and do a big bang release. We will come to the migration strategies later, but I would really encourage to do it side by side, and then gradually migrate the functionality and do a full round of user acceptance tests, etc. But getting back to our API, there is no difference here. The only difference is that we are just getting a specific business context, a specific business intention, and we are calling some specific logic, but we also need to map our API. So this is nothing different from the specific case. We need to store it somehow and return the result. So from the API perspective, if we haven't got here like get event store, then we wouldn't even know that we are just using event sourcing. Let's have a look on how we could model in our code events. So if you are not TypeScript developer, I know that Alex is doing some Node.js and TypeScript stuff from time to time at least. Then this might look either familiar or not. But what's most important is under TypeScript, we always have JavaScript. So to distinguish types and know which event is which, we need to define explicitly a type of our event. And type of our event is just a string, it's just a name representation. So our event is created from its type, its data, as I mentioned, specific data. And we can also have the some metadata. So if we have a look on this JSON event type, then it's just a basic definition of the typing. So type, data, metadata. And metadata can be like when event was recorded, it's for which user, etc. And I'm using direct typing from event store. So event store DB clients provide typing for events. I could write it on my own, but if I have them, then why not to reuse them? In event store, we can store not only JSON data, but also binary data. So if someone is using for example, protobuf, then you can also use the binary format. But let's get back to our shopping cart. So this is just our set of event. And this is also quite nice because by looking at our code base, we can see that for our shopping cart, we can record a following set of events. So the same as we defined in our sticky notes. And as we can see, they have the specific data, like the shopping cart ID and opened add for opening cart. For adding and removing product, we have a product item and also some additional data like when that happened. And for confirmation, we have also data about user. So this is also aligned of what we eventually stored in our database, like Postgres tables. So that's something that we gathered from them. And as you can see, as user information and additional informations were not mandatory, not required, then we always only have them in the last event. We don't need to gather all the states in all events. And TypeScript is great in a way that it allows to define union types. So we can say that this is the type, and shopping cart event will be either shopping cart opened or product item removed, added, or shopping cart confirmed. And by having that, let's just skip it, we can define our method of getting shopping cart. We will get into the stream aggregator star in the meantime, but what's the most important is that in event sourcing, we need to define method that will tell us, like having a specific state and an event, what would be the next state. So after we apply the event on our current state. So for example, and here we are using with the pattern matching with the switch, we can check what's the specific event type, and based on that, define a specific business apply logic for our current state. So if we expect that we will always have the first event as shopping cart opened, then we are returning a new shopping cart. And shopping cart, I forgot to show you, it's just a regular entity. So in our business logic later on, we won't be using events. We will be just using the regular entity, the regular type. So here we are taking data from events like shopping cart, when shopping cart was opened, and we are putting empty product items collection and shopping cart status. And then we are saying that if the product item was added to shopping cart, then we need to take what we already had in our current state and add this new product item from the event data. For when the product item was removed, then we are doing similar stuff, but we are saying that we are taking what we had and remove the product item from events from the product items collection. If we are doing shopping cart confirmed, then we are just changing the status. And let's go to stream aggregator, this magical looking method. It's a really simple method, in fact, because it says that for each event in our event stream, we will be calling the when method, so the one that I showed you just a moment ago. And for each event, we will generate a new state based on the previous one and the event that we just got from the collection. So we are applying event one by one. So at first, our state is empty. When we applied shopping cart open event, then we will have here the initial state, and then we will have a next round. And again, we will apply next event on already known state. So is that clear enough, or should I expand on that? Okay, silence. So I'm taking silence as, yeah, it's clear enough. Oh, thanks, Alex, for feedback. Then let's have a look how the business logic could look like in event sourcing. So of course, we could use some DDD structures like aggregates, but as I mentioned, we can define our current state as a regular entity. Let me find where it is. Yeah, it's here. So we are saying that our shopping cart will look like that. Nothing fancy here. And we can use this shopping cart in our business logic. So if we have a command definition that add product item to shopping cart, and we are providing shopping cart ID and product ID, then our logic will look like that. We can define a method that will take the events, all the events from database command, and get and maybe some additional uh, injection of the function like get product price. So at first, we are getting the current state from events, and this is the only difference. But then we are just running the regular logic. So we are just doing some validation, like making sure that our shopping cart is not closed right now. And then we are calling maybe some external service to get price of our product. And having that, we are just generating and returning new event. And the same pattern applies to all the other methods. So we have a comment, we have the current set of events, and we are at first getting state from events, then we are doing validation, running business logic. So for example, making sure that we can add product, and then returning an event. And for me, that's really easy and helpful because that gives us option for really simple unit testing and just making sure that um, that we are putting some input on one hand and one side, and then we expect some result on the other hand. So that also simplifies our business logic and make it more predictable, because we know that as a result, we always get a specific event. So let's have a look on how that looks in Event Store DB. So how we could store it. So I defined a method that's called update, and update takes a Event Store client and our command handler. So we are sending them events, command, and expecting as a result some event. And our method will look like, we are calling the event store client to get all events from the specific streams. So for example, specific events for the shopping cart. Then we are putting those events into our handler that you just saw together with the command. And as a result, we are getting event. And then we can pass this event to our event store client and call method append to stream. And append to stream will just append a new event at the end. And what's important here is that event store are supporting basic promises of the databases, because as I mentioned, they are just databases. So all the appends are atomic, and you can use, for example, optimistic concurrency to make sure that you are making decision based on the latest state. And most of the event stores I know, not all, but majority, also allows to have a read your own rights promise. So you are getting a full strong consistency also on the right side. Not always on the read side, but that's another story. So any questions to that part? Hi, Stephen. I see that you joined in the meantime. So, okay, let's get back to, again, to slides. So, and let's maybe briefly discuss again how we could store it, just to summarize what I just told. So event sourcing by itself does not speak about the type of storage that you should use underneath. So I can imagine, and I think that I will do it at some point, to create event store on top of Excel. And this is possible because you can store it anywhere, even in the Notepad. But typically, you either use the relational database. So you can use, for example, some set of data are always constant, the same set for each event. So for example, stream ID is our record identifier, type will be the event type, so the string name that you saw. ID will be unique ID for the event. Serial number, there are different names like serial number, position, revision, version, but in the end, it's just a position within the specific stream. So we were able to decide and find the order of appearance for the events. Then some additional metadata, like when this event was recorded, and we could use either text text field or a JSON-B field. So if you are using Postgres, then Postgres has great support for JSON storage, and that's what's based for Martin, which is a .NET framework that I'm co-maintaining, as you might know. And but the other solution is to use the binary format and store those events just directly on disk. And this is how Event Store DB works. So it is a database that was natively created for the event storage, but not only event store right now. DB is the only database focused on that. I know that in a Java land, there is Axon framework. They started as a CQRS framework, but right now they also came up with their own files. Because as you saw, we have only two types of operations on event store. Give me all events from the specific stream and append event at the end. Of course, we can expand on that, but those two methods will be enough to implement event store. So having that gives us plenty of options for the optimizations of also on the storage level. So that's where databases like Event Store DB shines, because you can optimize everything based on that usage. And okay, let's maybe discuss how we can build read models, because we discussed so far how we can run the write model and how we can store information. But if we would try to get all of the events from all the shopping carts to display shopping cart lists, then that wouldn't be effective, because we could potentially get an enormous number of events. And if we would need to apply all of that in the memory, then that could take some time. So for that, we have a projection. We have projections. And projections, we could say that this is just an interpretation of the same subset of events. And on this photo, you can see Muhammad Ali and Sonny Liston. And as you see, the same result of the same fact can be interpreted totally differently. So for Muhammad, that means victory and happiness. For Sonny Liston, probably dizziness and not great atmosphere in the evening. So as you can see, the same business fact can be interpreted differently. And that also applies to events, because projections are just a different interpretation of the same set of events. So we could take a set of events, like, for example, all the events from the shopping cart, and flatten them and put them and store them in some other database that is natively designed for like a set-based filtering and set-based operations. So projections can be created from the same stream, for example, from the shopping cart, or can be created and be result of the transformations of the multiple streams. Like if we have a user cards dashboard, then we could have, for example, the dashboard created based on the user events and shopping cart events. And how to do that? The basic approach is called left fold. So we are just taking data what's on the left side and moving into the right side. So we are taking event one by one and apply it on top of the, for example, relational database row. So if we are getting the shopping cart open, then we are creating new record in database. If we are adding product, then we are updating or adding new record. If we are confirming, then we are modifying that. So we are applying even one by one on top of the state. So this is the same pattern that we used for getting our data in memory, but here we are just applying it once. Once we got notification that the event was recorded. And what's the killer feature, in my opinion, for event sourcing is that the single event can change multiple read models. So for example, if we are adding product and recorded product added, then we need to update the product availability, shopping cart view, and maybe some administration user dashboard. And why is it a killer feature? Because we can offload our brain. So this is also called like a cognitive load. So how many information we need to process at once to be able to be productive. And event sourcing allows us to split the process for business logic and focus on how to run the business logic the best we can and generate new business event, and then how to build a read side of things. And that can be, even if we recorded all of the events, then we could even create a new views from then in the future. So let's say that, as I described at the beginning, we came up with the basic information like shopping cart view, but then our business said like, yeah, we would like to get a new report. I'm sure that you had such cases in your past that business always wants to get a new reports. And if we have this information recorded from event, then we can build our read models based on that. Of course, not always it's so perfect like that, but it at least gives us the chance. And projections may also create other events because it's not say what projections should generate. It can, for example, also generate PDF file, because why not? It's just the interpretation of events. And projection, what is not enough underlined, is that projection can have a strong consistency. We do not need to have eventual consistency. It's a matter of the technical implementation. If we are, for example, using the relational database underneath, like Martin can do, we can store event and update read model within the same database transaction. So we can get the strong consistency. Of course, that's not the solution for everything, because if we have one even modifying multiple read models, then that can impact performance of our write model. So it's better in the end to come up with the asynchronous process of updating projections when we see that we are too slow. And that's also this mechanism is named subscription. In Martin, it's async daemon, but typically that's named subscription. So it's like a PubSub database, like even StoreDB or Martin will inform us, notify about the new event. And then we can decide what to do with that fact. So we can update read model, or we can push it and forward that to some queue. And that let's skip for now. And let's get back to our initial discussion. So how to transform our CRUD architecture into the event sourcing. So this is how it looks right now. So the first step that I would suggest is to put on top, if we started, we have the working system, so we do not want to break it, then we could set up in parallel a different environment. And this breakdown that I show you in the code, so having a different project and different code base for CRUD and event sourced part is a base for that. So we can put, for example, a reverse proxy or load balancer that will be sending the same request to the production, the current production, and also to the event sourced part shown like deployed in parallel. And for some period, we can handle those requests both in our CRUD system and in our event source system. What's more, we can use the projection mechanism to store the result of our business logic and our projections also in the same database. Best if it was a different schema or different database. And we can compare the results of both business logic. So the business logic that we have right now and the business logic that the written event sourced logic. So then having those data in parallel, then we can see, yeah, okay, we have the same set of data for both sides. Then we might decide that at some point we would like to throw away this old one. However, I would really encourage to really make sophisticated tests and run it for some time to see what can go wrong, to understand also the operation side of things, because event stores are not always the easiest database to maintain, especially those that are crafted for event storage and different than traditional ones. And usually it requires a few iterations because we won't create that always right. So that's why I'm suggesting to keep for some time, keep those systems in parallel and then make sure that we have them operational. So after that, when we see that our event source part is okay, then we can use the strangler pattern and either remove all the old system if we manage to make a full transition, or just replace some part of it. So for example, only updates or only creation will go through the old one or through the new one, and the rest will go through both. So we can do a step-by-step transition. It all depends on our case. And when we have it, then when we have this business logic, then as I mentioned, we can store them in one place and in another and understand what's going on. Then we also need to think about how to migrate old data, because this scenario will allow us to maintain the new one, the information that we registered by the API, but we already have the old data. So we should think how to do it. And we can use the same business and the same thought process that we use to find out those events based from the database storage. And we can take those information that we currently have in our old database and try to run the background process that will be taking those records and translate them into events. And there are two general ways of doing this transition. The first one is to just set an initial event, like a initial shopping cart initialized or shopping cart migrated. And we are saying that we don't know precisely what's the state. This is the data that we had, and take it from there. Or if we have more time, then we could try to base on the thought process that I described previously. So having a look, for example, on status columns or on some data like non-required column states, etc. Define set of events, and maybe, for example, if we know that the status is confirmed and we see that in the shopping carts product items table we have some data, then we could generate the shopping cart opened and then product item added to shopping cart, and in the end shopping cart confirmed, and store the set of events from those rows in database. And once we have it, we can put it into the event store. And again, it would be good, before we just optimistically assume that we were right, it would be good to push it through the whole process. So again, push it, build projections, and when building projections, make sure that the projections results are exactly the same as we had for the for the data that we were importing. So again, I really encourage to do a step-by-step process. And having projections and event source system is also great for that part, because our source of truth are events. So projections are predictable for the same set of events. If we have the same set of the same business logic, then we will get exactly the same results. And if we modify the business logic, then we could even delete all the read models, push the events again through the projection logic, and regenerate projections. So this is not only useful for the migrations, but also fixing bugs, expanding and extending read models. So how to do it? We could use the in-place rebuild, which is the easiest way. So we are truncating the current state of database and then applying again even one by one. And of course, that's not always viable, because we might be needing, for example, preferring to have potentially wrong data or not full data, but something that is up to date. And we might not be able to decide that that we will have some downtime. So for that, we could use a blue-green rebuild approach. And this blue-green rebuild approach is quite similar to what I described you as a try to compare the data. So we are creating an additional table. It might be different table, different schema, different database. And we are applying on it events. And once the new read model caught up, then we can switch and say that, yeah, this is from now on the new read model. So this is quite cool. So coming to an end, we went through the whole journey. I hope that you see how even from the basic CRUD business feature, we can benefit. So by getting more information, getting more tracking, we can expand our business model. We can get benefit business-wise, because I can guarantee you that business people love to have more data. If you ask them, do you want more data? Sure, they will, at least majority. We can get a much more insights. We can get much more diagnostic from the business side, even for the support. Like, let's say that someone said to us that I got a Witcher, but I ordered Cyberpunk. And we can take those events, or support can take those events and see that, yeah, okay, this guy in fact ordered Cyberpunk, but then he decided that he don't want Cyberpunk and decided to take Witcher. So that can also support us, not only technically, but also business-wise and support-wise, to make our system more predictable and make our life easier. Even for the bug, if we are debugging, then we can take the subset of data from production, debug it locally, and we will easier know what has happened. So we can get also auditability. So by storing information about correlation, so which request ID triggered those events, then we can get all of the set that was generated. And by causation, we can say that store as a causation ID the ID of the thing that triggered this event. So for card confirmed triggered command confirm shopping cart. For card confirmation email sent or pro forma invoice issued, we can store a event ID of the card confirmed. And based on that, we can build such a nice tree, and we can see together what caused that and what's the correlation. So we get better auditability, which in the cloud system and distributed environment is critical. And so in summary, I hope that that gave you at least the starting point of how to migrate and why you would like to consider migrating from the CRUD system into event store one, event sourcing one. And I hope that I show you the basic patterns and basic examples where to start. Of course, it's not always as easy. Each migration is always hard. We can expand that if you'd like to on the next webinars. I encourage you to send me some ideas of what you would like to see next month, because I'm planning to run such webinars at least once per month. And so, yeah, that's all. Thank you a lot. And I hope that you enjoyed that. And we will start soon the Q&A session. Let me just stop recording so we could just talk openly.